Right, Algebra 2, we are talking about synthetic division some more today, but now we're kind of putting it all together and writing the remaining factors as one big polynomial. So our steps here, step 1, use synthetic division to find the depressed polynomial. Okay, so let's go ahead and do that part actually, step by step. So here's our factor. So remember, we're going to use the opposite of that factor, which is -5 in this case. So -5's in our little box. Then we've got 1, 2, -13, and 10. Bring down that leading coefficient, and we're ready to go. So 1 times -5 is -5. 2 plus -5, that's -3. Negative times negative is +15, that's +2. 2 times -5 is -10. And we get our remainder of 0, which means it checks out. And we rewrite this as a polynomial. So x squared minus 3x plus 2. And so that's what we did yesterday and the day before. But now we're going to take that and find the remaining factors, or use factoring to find the remaining factors. Okay, so in this case, we're going to say, okay, well, what two factors of +2 give me -3? And you would say 1 and 2 give me 3, but since it's negative, I need -1 and -2. So that's going to give me x minus 1 and x minus 2. And there we go. So step 3, write all the factors together as one polynomial. And so our final answer here is x minus 1, x minus 2, and then the original, which was really up here, x plus 5. And you can say y equals those, or equals 0, or just write them right now. That's not a big deal. Okay? And there we go. That is our final answer. That is the depressed polynomial and completely factored. Okay, so that's what we're doing. Going to take the factor they give us, use synthetic division, and then find the remaining factors, so what's left. So here I've got +2, so 2, I've got 1, 1, -10, and 8. And we're ready to go. So 1 times 2 is 2, that's 3. 3 times 2 is 6, that's -4. -4 times 2, that's -8. So it checks out. And that gives me 1x squared plus 3x minus 4. And so now we go ahead and factor. So what two factors of -4 give me 3? And I would say 1 and 4. But since it's +3, I want +4 and -1. So -1 and +4. So my final answer, x minus 1, x plus 4, and then the original x minus 2 from up top. And there we go. So again, it's not really much different from what we did yesterday. It's just kind of adding in that factoring part. Okay, so x plus 4, that means it's going to be -4 for my number. So it's 1, -7, -26, and +72. Bring down the 1. 1 times -4 is -4. -11. -11 times -4 is +44. And then that gives me, what, 18. 18 times -4 is -72. I think that's right. Yeah. And so what we have left is x squared minus 11x plus 18. And so now we're going to factor that. What two factors of 18 give us negative 11? 1 and 18, 2 and 9, there it is. Since it's a negative 11, I want positive 2 and negative, never mind. We need both of them to be negative. And so negative 2, negative 9, and so our final answer is those two and the original x plus 4. And there we go. So here's our last one, and then we'll go to the back side. Again, x plus 4, this time we have negative 4 for my box number. So 3, negative 1, negative 62, negative 40. Let's go. Bring down the 3. I've got 3 times negative 4 is negative 12. That's negative 13. Oops. Negative 13 times 4, that is 52. 52, that's negative 10. Negative times negative is positive 40. Again, 0, so that's good. 3x squared minus 13x minus 10. So in this case, we haven't done this in a while. Can't just factor this with x and x. I've got to do the slide rule. So that becomes x squared minus 13x minus 3 times 10 is 30. Now we do the same thing. Slide rule. Slide, divide, slide. So negative 30 to give me negative 13. That's going to be 3 and 10. So again, you can kind of go through the different factors, 2 and 15. Oh, actually, I was wrong. Because it's a negative, I need one to be positive, one to be negative. So that's negative 15 and positive 2. There we go. And so put those into the parentheses, but this time it doesn't really work. Because remember, when you slide, you must divide by that number. So divide by 3 here, divide by 3 here. This one slides up. I've got 3x plus 2. This one actually divides to get x minus 5. And then I have our original x plus 4. And there is our final group of factors. Okay? Little reminder of slide, divide, slide rule when you don't have an x squared in front. Okay? So let's go to the back side here. On the back side, it says pretty much the same thing, but we're using those factors to find zeros. Okay? So, for instance, the zeros here would be whatever you get when you make each of these equal to 0. So, like, the zeros for that one would be, for like the last one here, x equals negative 4. X equals positive 5. And then this one, you subtract 2 and then divide by 3. You get x equals negative 2 over 3. So we didn't have to do that on the front, but that's kind of how this is going to work on the back. And for these first two, I'm going to go ahead and actually graph these as well. And we'll talk about that a little bit here. But first, let's go ahead and find our factors, because those are also going to be my zeros. So 2, I've got 1, 3, negative 6, negative 8. Bring down the leading coefficient 1. 1 times 2 is 2, that's 5. 5 times 2 is 10, that's 4. 4 times 2 is 8. That gives me a remainder of 0, which is what we want. Okay, x squared plus 5x plus 4. And what two factors of 4 give me 5? 1 and 4, both positive. So plus 1 plus 4. And so my final factors are these two, and then the original x, well, it would have been x minus 2. So really, I don't need to write it out like that. I can just say, okay, the zeros are the original x equals 2 from the top, negative 1 and negative 4, because I'm just setting each of these equal to 0 and solving, which means it's just the opposite sign. So if those are the zeros, those are also the x-intercepts. Okay? These are the x-intercepts of my graph. So if I wanted to graph this, again, it doesn't need to be super detailed, but I would have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so this is just a sketch of the graph, but we need to know a few pieces of information. First of all, what is the end behavior? Okay, this is something we talked about last week, but all that means is where is this going to end up, to the left of our graph and to the right? So since it's x to the third, that means it's an odd number, which means it's going down one way, up the other. So it's going to end up looking like this on both sides. I don't know what's happening in the middle, but it's going to end up going down to the left, up to the right. Okay? Our zeros, or our x-intercepts, are the ones we just found, 2, -1, and -4. And then the other one we can always find is the x-intercept. So plug in 0 for x, which crosses everything out and gets me that last one, -8. And so -8 is my y-intercept. So I'm going to need to make that y-axis a little longer, but you get the idea. So 1, 2, 3, 4, 5, 6, 7, 8. Good enough. So there's 1. I've got -1 for the y-intercept, -4, 1, 2, 3, 4, and +2. Okay, so now, since I know what the end behavior looks like, it means the farthest left x-intercept means it's going down to the left, up to the right. And then I just kind of fill in from there. So it doesn't really say it's going to go anywhere there. It needs to go touch there and come back up. Now again, that's not a very good sketch, but it's not going to be perfect. That's why it's called a sketch. But that would be our basic shape of our graph. Okay? So let's do another one here. So x equals 2. That's one of my x-intercepts. I'm going to go synthetic division, 1, -6, 13, and -10. Bring down the 1. Let's go. 1 times 2 is 2. That's -4. -4 times 2, that's -8. Gives us 5. 5 times 2 is 10. There's our 0. So x squared minus 4x plus 5. And so what two factors of 5 give us -4? 1 and 5 do not give us that. So this one may not. I need to look at my key real quick to make sure I'm not telling you the wrong thing here. Yeah. So in this case, since it doesn't factor, we would go ahead and use the quadratic formula. So x equals -b, which is -4, plus or minus square root of -4 squared minus 4 times a times c all over 2 times a, which is 1. And so it's going to be a little messy here, but we end up with, what is that, 16 minus 20, so -4 over 2. And so the square root of -4, remember when we have a negative in the square root, that comes out as I. And then square root of 4 is 2, so 2i over 2. And so, since all three of these can divide, we can go ahead and divide all those by 2 to get 2 plus or minus I. And so that means we're not going to have any other x-intercepts there. So look at our end behavior. X to the third again, so it should be ending up like this again. And then x-intercepts only have the 1, x equals 2. And then y-intercept is right there at the end, -10. So let's make our little graph. I'm going to give myself some room on the bottom here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our y-intercept. 1, 2, and then everything else, we don't really know what's going on. All I know is it ends going this way. We can kind of assume it's going to go down there, come back up, and then it never crosses again, so it goes back down at some point. And there we go. Now, technically it could have gone, since we don't know where it is, it could have gone this way. Oh, never mind. Yeah, it could have gone like that. But again, that's just a sketch. You know what the end behavior is. You can kind of sketch out what you think it might look like with those intercepts. Okay? So last one. We've got -3 for the 0. So 1 plus, 1, +3, -7, -21. Bring down the leading coefficient, that's -3. That's 0. That's 0. -7. That's +21, which is 0. Good. So x squared minus 7. And so, in this case, I know that doesn't factor, so I'm going to actually use the square root method to see what the zeros are. So plus or minus 7, x squared equals 7, square root both sides. We get x equals square root of 7, which I don't know what that is, but it's going to be 2 point something. So square root of 7, it's going to be plus or minus 2.6 or so. Okay, so those are actually zeros. Okay, so look at our end behavior once again. It's going to be like this. X-intercepts are -3, and then plus or minus 2.6. And then y-intercept, we're not going to be able to fit on the graph here, is -21. Okay, so let's go ahead and get our graph figured out here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Doesn't need to be perfect. So plus or minus 2.6. So there's that and that. Oh wait, that was 1.6. Sorry. Try that again. 2.6 right there. 2.6 right there. And -3 just a little further that way. So in that case, since I know it's going to end behavior, I need to make sure I'm ending going that way and that way. What that tells me right here is it's not going very much farther. It's going that way, and then it's going way down here to -21 and coming back up. So it kind of would go off the graph if we could, all the way down to -21 and then come back up. Okay. So that's a little bit of review on end behavior, but everything else pretty much is what we've been talking about all week with synthetic division. Just maybe a little add-on to end behavior. So x squared means it's going to end like this. X to the third means it's going to end like this. And then if you put like -x squared, it's going to end like this, and -x to the third just flips it all around. Going to end like that. So again, just something to think about as you're graphing, and that's all I have for you on the notes. Peace.